If two atoms are present in connectivity with one another, let us consider A is an atom and B is another atom, and consider that these two atoms are connected with a sigma bond, whereas atom A is different from atom B, and you expect that the electronegativities of atom A and B are different. Let us expect in this case atom A is more electronegative compared to B. Though there is a sigma bond, the sigma bond appears to be present exactly between the atoms A and B, but here what happens is the electron density of this sigma bond is somewhat very much close towards A compared to B, so therefore A attains partial negative charge and B attains partial positive charge. Now here we can say this bond is exactly not a non-polar bond. We say it as bond is polar. That is, bond is having what? Polarity. So therefore bond is polar bond and bond is having polarity. Whereas this polarity is indicated with the symbol mu. Whereas if mu is not equal to 0, then we can say that molecule is what? Polar in nature. The reason for polarity is whatever the connectivity present between the atoms, if that connectivity is not so properly present in such a way that electron density is not equally distributed between the atoms, one of them is having higher electron density and other of them is having lower electron density, thereby electronegativity differences are there, we can say that bond is not polar, bond is said to be polar. But technically, to measure this polarity, which is indicated by mu, we are taking the help of whatever the charge separation is present, that is charge into distance of separation between the charges. This is taken as distance of separation between the charges is taken as formula to calculate the dipole moment. In short form, we can say this charge is C, whereas the distance of separation is what? D. That is the multiplication product of charge of separation may be either present on the first ion or present on the second ion, multiple times of distance of separation, nothing but what? Bond length. We can also say it as what? Bond length. The multiplication product of charge and the bond length related information provides us the quantitative information of dipole moment, that it is associated with the bond A and B. Though this mu, which will becomes equal to C into D, suppose if I go for CJ system of unit, if I go for SI system of unit, this SI system of unit will becomes equal to Coulomb meter. Whereas the CJ system of unit will becomes as ESU centimeter. Whereas the charge separation present between the atoms A and B, if we consider, this is a partial charge. If it is complete charge, this will becomes charge of one electron. Yes, if it is complete, then that implies what? Charge of electron, that is very small, 1.602 into 10 power minus 19 coulombs. So if I take coulombs into account, the total charge present is very much less compared to the coulombs. Hence, this particular unit appears to be very bigger before the quantity of the dipole moment obtained by the multiplication of C and D. Suppose if I go for ESU is also appears to be bigger compared to the charge separation present between the two atoms. Suppose if I go for ESU also, ESU is originally equal to 1 by 3 of 10 power minus 19 coulombs, but whatever the charge separation is there, that is very small before of this particular ESU. Hence, we are going for a derived unit for the measurement of the dipole moment. Yes, the derived unit is smaller compared to CGF system of unit. Whereas the CGS unit that we are expecting is ESU centimeter. Whereas compared to this ESU centimeter, a smaller quantity we are choosing, that is 10 power minus 18 ESU centimeter. This is claimed as a new unit for the measurement of dipole moment, which is known as what? Dy. Whereas this, suppose if I want to understand in a clear version, 10 power minus 10 ESU units multiples of 10 power minus 8 centimeter units. That is, every 10 power minus 10 parts of ESU is taken as reference for charge, whereas 10 power minus 8 centimeters is taken as reference for the distance. This is known as Armstrong unit also. Yes, this is known as Armstrong unit also. Whatever the bond length is present between the A and B, if I express in terms of Armstrong units, that every 1 Armstrong unit is taken as reference as distance. That is, d by is found to be equal to 10 power minus 18 ESU centimeter. If I express this dy, that is 10 power minus 18 ESU centimeters in terms of SI system of unit, it will becomes, whereas 10 power minus 18 is as it is, 1 ESU is found to be equal to 1 by 3 into 10 power minus 9 coulombs, whereas 1 centimeter in meters if I write, that is 10 power minus 2 meters. If I multiply all the multiples at once, this is 10 power minus 18 into 10 power minus 9 into 10 power minus 2 into 1 by 3 of coulomb meters. This will becomes equal to S minus 20 minus 29, that is 10 power minus 29 times of 1 by 3. Can I write it as 10 by 3 into 10 power minus 30? This is coulomb as well as meters, which is found to be equal to 3.33 into 10 power minus 30 coulomb meters. That is 1 dB, which is very smaller unit, whereas if I express that one in terms of regular SI system of units, its value is found to be equal to 3.33 into 10 power minus 30 coulomb meters. If I write all the units interrelations at once, 1 dB will becomes equal to very smaller unit compared to the CGS system of unit, that is 10 power minus 18 ESU centimeters, whereas that is, if I write in a proper version, becomes equal to 10 power minus 10 ESUs, 10 power minus 8 centimeters. If I express that one in terms of coulombs as well as meters, that will becomes as 3.33 into 10 power minus 30 coulomb meters, because as we know, every electron charge, that is 1.602 into 10 power minus 19 coulombs, will becomes equal to 4.8 into 10 power minus 10 electrostatic units.